In 1977, NASA launched the Voyager spacecraft to explore the outer reaches of the solar system. Decades later, both probes have passed the outermost boundary of the solar system, and what they found has amazed scientists. As they entered interstellar space, Voyager 1 and Voyager 2 detected a sudden temperature increase of up to 50,000 Kelvin, a region of hot plasma that marks the boundary of the sun's influence. In this video, we'll explore what Voyager discovered at that boundary, what causes this so-called firewall, and how it's reshaping our understanding of the boundary between our solar system and outer space. Let's get started. When Voyager 1 and 2 left Earth in the late 1970s, they were expected to complete their survey of exoplanets. No one expected that, having achieved their goal, they would continue their journey without a return ticket into the unknown dark region, where the sun's energy wanes and interstellar space begins to speak. Along the way, they quietly recorded the steady decline of the solar wind, the stream of charged particles that is considered the breath of the central star. This was consistent with the decades-old hypothesis that at an unimaginable distance, that stream would collide with the interstellar medium, the thin layer of matter that covers the galaxy, forming the Heliosphere, the invisible wall that protects the solar system. The turning point came in 2012, when Voyager 1 unexpectedly crossed this boundary, becoming the first man-made object to move outside the sun's arms. 6 years later, Voyager 2 repeated the feat, confirming unusual measurements of plasma density and magnetic fields outside the heliosphere. What surprised scientists were the signs that interstellar space was anything but quiet. Higher than expected particle densities, mysterious fluctuations in plasma, and magnetic field variations that didn't seem to fit theoretical models. A series of bizarre hypotheses have emerged. Is there a magnetic membrane surrounding the solar system as a natural shield? Does the interstellar medium contain energy structures we have never seen before? Some researchers have even asked the bold question, could the strange variations in the data be a sign of an unnamed cosmic phenomenon, or worse, a form of noise from an unknown source? While the scientific community scrambles to explain, science enthusiasts are preoccupied with conspiracy theories. Did Voyager really just detect interstellar plasma? Or did it accidentally hit some kind of artificial boundary constructed by an alien civilization? And if there is something unusual outside the heliosphere, are these two tiny spacecraft silent witnesses sending back the first clues to a story larger than the solar system? Voyager continues to hurtle through the endless darkness, its batteries running low, and its signals sometimes only a faint pulse across tens of billions of kilometers. But each packet of data it sends back, however small, carries the potential to shake humanity's perception of the boundaries of its cosmic homeland. The biggest question, to this day, no one dares to confirm, have we really gone beyond the solar system? Or have we just touched the first layer of a door leading to the deep universe with secrets beyond imagination? As they approach the intersection of the solar wind and the interstellar medium, both Voyager 1 and Voyager 2 recorded something that stunned scientists. Plasma temperatures soared from 30,000 to 50,000 Kelvin, 54,000 to 90,000 degrees Fahrenheit, an extraordinary change in a region that was considered nearly empty. The first question was whether the sensors were malfunctioning, but every measurement matched perfectly, forcing researchers to confront a new truth. There was a strange layer of space, a kind of transition zone that had never been clearly described, at the edge of the solar system. Rather than a solid wall, like in science fiction, this region is actually a layer of superheated plasma, where the weakening solar wind is compressed by the pressure of interstellar plasma. The collision between these two streams of matter creates a huge shock of energy, enough to heat particles to extremes. Because of its violent and vague nature, like an invisible curtain of fire, the phenomenon has been given a mystical name, firewall of the solar system. Although its name conjures up images of a giant cosmic furnace, the region posed no real threat to Voyager. The plasma density is extremely low, less than 1 particle per cubic centimeter, making it a poor conductor of heat. The spacecraft simply skimmed through this turbulent boundary, leaving behind the first direct measurements from the farthest reaches of the sun's influence. These data confirm that the edge of the solar system is anything but static. Rather, it is a complex, dynamic region where pressure, plasma flow, and magnetic fields twist and turn, creating a natural boundary that separates the familiar world around the Sun from the vast alien interstellar ocean. This chaos immediately raises a number of challenging questions. Why did the temperature rise so suddenly and to such an absurd degree? Is there an undiscovered physical mechanism governing this region? Some scientists theorize that the firewall could be a giant magnetic field surrounding the solar system, acting as a natural energy barrier. More daring theories, often considered fringe, suggest that it could be the remnants of an ancient cosmic structure, a warning barrier created by a long-lost civilization. Voyager crossed that boundary, leaving behind a blazing wall of plasma, a sign that the universe is far more complex than any model humanity has ever built. And the biggest haunting question remains unanswered. Beyond this firewall, how many unknown boundaries lurk in the interstellar sea? Voyager's record-breaking journey turned a once theoretical concept into a measurable reality. The outer edge of the Heliosphere, the magnetic bubble that surrounds the entire solar system. Data collected shows that this structure is not only vast, far beyond the orbits of the planets, but also more powerful and complex than previously thought. The heliosphere, a natural shield against harmful cosmic radiation, acts as a defense mechanism for cosmic immune system, constantly reacting to fluctuations from the sun. At the edge of this giant shield, where the solar wind slows down, compressed by the interstellar medium, a powerful heating occurs. NASA likens this process to the bow wave of a ship cutting through the water, creating a sudden increase in pressure at the point of contact. Voyager recorded plasma temperatures rising from 30,000 to 50,000 Kelvin, a clear sign of the collision of two winds, the inner solar wind and the outer interstellar wind. Although called fire, this phenomenon is not a chemical combustion, but rather an acceleration and energization of charged particles. These precious data have helped scientists begin to sketch out the true shape of the heliosphere and at the same time raised new mysteries. How can such a massive structure maintain a stable shape in the turbulent plasma of space? Does it oscillate with the sun's 11-year activity cycle? And more importantly, are there undiscovered factors in the interstellar medium that are driving this structure? Some modern theories even suggest that the heliosphere has a self-regulating nature, akin to the behavior of a living organism, reacting to its environment to protect its interior. This opens up a bold line of thought. Could the heliosphere be a distinctive energy signature of star systems, a signal that other civilizations in the universe could pick up from afar? Even within the cosmology community, there are suggestions that the strange stability of the heliosphere's outer edge could be the remnants of some ancient form of galactic natural engineering, or even the remnants of a civilization that once controlled plasma and magnetic fields at a level unimaginable to modern humans. While mainstream science doesn't support this idea, the heliosphere's outer edge, with its hot plasma and unexplained signals, still feels like humanity is just entering the first door to the universe's many secrets. Thanks to Voyager, the theoretical boundary has become a real space where energy particles collide and create signals that defy all human understanding. And if this is just the outermost layer of the solar shield, then the other side may contain a series of secret layers waiting to be discovered by the next generation of explorers. One of the most striking aspects of the Voyager pair is the distance they have traveled to escape the heliosphere, the region of space dominated by the Sun. Voyager 1 crossed this boundary at 121 astronomical units, while Voyager 2 did so at 119 astronomical units. The seemingly small difference has huge implications. The heliosphere is not a static structure. It contracts and expands like a cosmic lung, inflating when the sun is active and contracting when it is quiet. The boundary surrounding the solar system is thus like a living membrane, a dynamic skin that responds moment by moment to the amount of energy the sun pumps into space. But it was the magnetic data the spacecraft returned that really surprised scientists. For decades, theoretical models predicted that the magnetic field in the heliosphere would be tilted sharply from the magnetic field in the outer galaxy. But reality told a different story. Voyager recorded that the two magnetic fields were nearly parallel, creating a smooth, continuous transition rather than a sharp dividing line. The discovery forced space physicists to reconsider basic assumptions about how the sun interacts with the interstellar medium, an interaction that may be far more complex than previously thought. These results reveal that the boundary between the sun's influence and the interstellar sea is not a hard wall or a sharp line. Instead, it is a delicate blend where magnetic fields twist, mingle, and interact. Energy from the two intertwined environments flows back and forth, creating a dynamic intermediate zone that is more complex than previously imagined. And this strange mix opens up a whole new set of questions. Does the transition zone form stable energy flows, magnetic rivers that wind along the boundary between the two worlds? Does the unexpected parallelism of the two magnetic fields hint at a larger structure in the galaxy, an invisible web of magnetic fields that connects star systems? Some bold hypotheses even ask, could the blending zone act as a natural gateway, allowing high-energy particles or undiscovered phenomena to pass through? It was Voyager that helped us recognize that the edge of the solar system is not an absolute cosmic boundary, but a soft and volatile transition zone, where the laws of the sun begin to melt into the broader laws of the galaxy. And it may be that mysterious intersection that holds the key to understanding how the universe works on enormous scales. Beyond magnetic fields, Voyager data also help reveal how cosmic rays, ultra-high energy particles released by cataclysmic events like supernovae and black holes enter the solar system. The Heliosphere acts as a semi-permeable barrier, neither completely blocked nor completely open. Most cosmic rays are deflected by the sun's magnetic field and plasma, but some still get through, depending on how active the sun is at the time. When the sun is active, the solar wind thickens and the heliosphere expands, significantly reducing the amount of cosmic rays that enter. Conversely, when the sun is weak, the shield thins, making the inner space more permeable to energetic particles from deep space. Understanding this process has direct implications for the radiation environment throughout the solar system, from Earth orbit to human voyages into deep space. Understanding the heliosphere's cosmic ray filtering mechanism will not only protect astronauts, but also aid in the planning of future interstellar routes. Projects such as Orion and other ambitious interstellar travel concepts will require this kind of knowledge to ensure human survival in environments where the sun's familiar influence is fading. All these findings confirm that the boundary of the solar system is not a static border, but a living, flexible structure, constantly changing with the breath of the sun and the pressure from the invisible energy flows of the galaxy. It is like a thin but flexible skin that covers the solar system, stretching according to the intensity of the sun's anger or peace, and constantly reacting to the pressure of interstellar space. The existence of such a breathing boundary layer raises a big question for science. Does each star system have its own heliosphere with different shapes and characteristics? Can the structure of each heliosphere reveal clues about the possibility of life or the evolutionary history of planetary systems? And more deeply, if humans one day enter interstellar space, will we be able to directly sense the transformation of that boundary like Voyager did? Voyager has demonstrated something important. The solar system does not end with a sharp boundary, but with an energetic boundary where the sun and the galaxy meet. And it is at this dynamic, mysterious boundary that humanity's exploration of the universe may just be beginning. Voyager's passage through the heliosphere was not only a technical feat, but also the first time in human history that a man-made machine had entered interstellar space directly. This was no longer an indirect observation through a telescope or a simulation, but the actual presence of an artificial messenger outside the final protective layer of the sun. The data Voyager collected at this boundary helped scientists build more accurate models of how the solar system interacts with the galaxy, as well as how the heliosphere acts as an invisible shield against the violent radiation that permeates the universe. Understanding the rhythm of this natural shield's expansion and contraction is key to predicting space weather, a vital component in protecting electronics on spacecraft, space stations, and especially astronauts on missions lasting months or years. The heliosphere's rhythmic fluctuations, like the beating of a cosmic heart, directly regulate the radiation levels that future missions will face. Voyager's findings extend far beyond the solar system. In the galaxy, each star creates its own protective layer, similar to the heliosphere, called the asthenosphere, that determines how much radiation reaches the planets in its system. These layers influence the ability of a planet to retain an atmosphere, maintain liquid water, and sustain life. The boundaries Voyager measured now serve as standard data, allowing scientists to model how other stars protect their planetary systems. By understanding how the Sun's heliosphere works, researchers can better assess which exoplanets lie in their host star's safe zone, a zone where cosmic rays are sufficiently reduced for life, whether primitive or complex, to develop. Some models, even more boldly, suggest that stars with particularly large or stable heliospheres could form island universes, where life is more likely to thrive than systems with weaker heliospheres. Voyager provided the first direct look at the boundary between the Sun and the galaxy, and from that boundary, the prospect of searching for life beyond Earth became more scientific and feasible than ever. The journey of the two aging probes continues, and each faint signal they send back tells not only the story of our solar system, but also reveals how the universe nurtures or destroys life on worlds we have never visited. Now, both Voyager 1 and Voyager 2 are whispering back fragile signals across vast interstellar distances. NASA engineers carefully manage every last watt of power, shutting down non-essential equipment to maintain the most important sensors. Each signal, as faint as a breath, contains invaluable data on plasma density, magnetic field strength, and cosmic rays in interstellar space, regions unexplored by any other spacecraft. These signals are like the first strokes on a map of a world no one has ever seen. But the power source for these enduring machines is running out. Their radiogenic thermoelectric generators, RTGs, are weakening with each passing year, and by around 2030, Voyager will no longer have enough power to operate even a single instrument. At that point, the two spacecraft that have served for more than half a century will fall silent forever, no longer able to whisper to Earth. But that silence does not mean the end. Though they no longer transmit signals, Voyager will continue its endless journey, drifting among the stars for billions of years, like two fragments of human consciousness silently passing through the Milky Way. What is special is that each Voyager spacecraft carries a golden record, containing sounds, images, and greetings from Earth. It is the sound of children laughing, thunder, ocean waves, wind blowing through trees, and greetings in dozens of languages sent to any intelligence that may find them in the distant future. Those golden records are like messages released into the cosmic ocean, witnessing the existence of humanity, perhaps more lasting than any construction, any civilization, even the Earth itself. Voyager's existence has sparked a number of bold hypotheses. Will a distant civilization find them millions or billions of years from now? If so, will they be able to decipher the message engraved on the golden disk? Will they see Voyager as an artifact from a long-lost civilization, or as a greeting from a creature looking for friends in the universe? No one knows the answers, but the very existence of these questions makes Voyager's journey so sacred. Whatever the future holds, the Voyagers have carried humanity's first voice beyond the reach of the Sun. They will continue to drift, silent but immortal, as two cosmic witnesses telling the story of the blue planet to anyone lucky enough to listen in the distant future. And even when the light of human civilization has long since faded, those little machines will still be there, carrying Earth's eternal greeting to the entire cosmos. Future missions are being planned to pick up where Voyager left off, extending the exploration of the mysterious interstellar space that the two pioneers pioneered. NASA has proposed a next-generation interstellar probe that would fly 3 times farther than Voyager and carry advanced sensors capable of mapping the entire structure of the heliosphere with unprecedented precision. In addition to surveying the outermost boundary of the Sun's influence, this future probe would analyze the interstellar medium in detail, from the composition of plasma and magnetic fields to the way high-energy particles move between different regions of space. Such missions could answer the big question that Voyager inadvertently posed. Was the super-hot wall they passed through a unique feature of the Sun, or a common phenomenon that occurs around every star in the Milky Way? If every star has a similar energy boundary, it would radically change how we imagine the structure of our galaxy, and could even redraw the map of the interstellar medium in a whole new way. Voyager's findings have proven that the edge of the solar system is not the silent darkness that humans once imagined. It is a superheated boundary, filled with plasma, energy fluctuations, and powerful interactions between two worlds, the inner breath of the Sun, the outer endless interstellar sea. What is amazing is that nearly half a century later, Voyager continues to deliver new clues, continuing to extend humanity's reach into a space that was previously only theoretical. At the edge of the solar system, Voyager did not find the absolute void that many had imagined. Instead, it detected the pulse of a living sun, still interacting with the wider cosmos through its own particle streams, magnetic fields, and plasma breath. That boundary was not the end, but the beginning of a larger story, the solar system merging into the galactic sea, and humanity beginning to understand its role in that vast space. Voyager opened the first door. Future missions will cross that threshold, travel farther, look deeper, and perhaps one day explore not only the boundaries of the sun, but also the mysterious workings of the galaxy, where each star may have its own heartbeat, the first echoes of which we have only just heard. If you want to continue to accompany us on our journey to explore the mysterious universe, don't forget to click subscribe to the channel so you don't miss any of the great stories waiting to be told on the other side of the sky. See you soon.